yeah, today we'll have a short primer and maybe deep dive into graph theory and heuristic based search. Now, I hope you guys were able to watch the intro to graphs, BFS and DFS lessons that I uploaded on Canvas last week. Today we'll have a sort of review on that, no, to hopefully clarify any questions you guys have and work on heuristic based search methods, so informed search, and what this generally revolves around, no? Okay, first off, are there any questions regarding what I just discussed, regarding the previous lessons, graphs, breadth first search, and depth first search? Wala naman. Sure kayo? Okay, cool. Sige. I will now share my screen. How do I do this? Okay. Oh, wait. Sige. Oops. Yeah. Okay. So if you can see my screen here, let's set it up accordingly. So dark. Something like that. Okay. Kita naman guys, okay naman. Let me know if there are questions lang. Sige. So just a short recap. Yeah, so graphs are what we use to represent the world. No? They're relational structures that we use to formally represent a network or a collection of somewhat interconnected dots. No? So it's a formal mathematical definition, representation of a network or collection of nodes and edges. So when we say collection of nodes and edges, no, what does this really mean? So we have previously defined this as the following. No? So some graph G will equal to the collection of vertices or nodes and edges, no, or links if you have that, where V is the set of nodes that you have. Oops. Yeah, do take note that some language calls them, I don't know, vertices. I think it's more, yeah, sorry, this is my bad. It's more appropriate to call these vertices rather than edges. Rather than nodes. But do note that they can be called nodes. Edges can also be called links. And how it would look like would typically be something like this. So let's define something here. Let's have here, oops. So have here 1, 2, 3, 4, 5. Yeah. So this is kind of bad. So let's call this A, B, C, D, and E. So our graph here would be some graph define the V set and the E set, the vertex and edge sets. No? So V now is equal to our set A, B, C, D, and E. And our edges, note that edges are mapped as the tuples, no, that connect the various vertices that we have. So it will look like something like this. So here I have an edge between A and B. So edge A, B. So let's check that off so that we know that we've hit that. Okay. And then we also have edge AC. Okay. And then we have edge BC. I'll just keep on doing this so that we move on quickly. BD. BE. And ED. So this defines this graph. No? We have our vertices A, B, C, D, and E, and our edges. Now for an undirected graph, do note that this is an undirected graph. No, the pairing of edges, the ordering of how we define the edges, does not really matter. So we could declare this edge here. Sorry, we could declare this edge here as something like edge AC, or it could be edge CA, but we can't have both. No. If we work in a directed graph, the order matters. So edge AC will be now different from edge CA. It's, think of it as a one-way street. No? It's unique one way from the other direction that you process it. So here we have essentially the size of V equals 1, 2, 3, 4, 5 nodes, and the size of E, our edge set, 1, 2, 3, 4, 5, 6. We have 6 edges. So 1, 2, 3, 4, 5, 6. Okay, it's good. Okay. Now moving on to informed search. No. So give me one sec. Let's have some network here. Sorry, just feel free to chime in or message if you guys have any questions. Okay. So let's work with a hypothetical universe where this green node is our start node and our blue node here is our finish node. Okay. So let's call this Katip. Let's call this Makati. And the objective is to traverse the path from Katipunan to Makati using some heuristic. And there are various nodes, various paths that we can all take. So let's define this one path here. Okay. Let's define another path here. Oops. Find a different path here. Okay, so let's define these landmarks now. So let's call this topmost route, maybe the C5 route. So let's say this is Eastwood, and then this is maybe C5. Let's all call this C5. Ortigas. Once you're past C5 Ortigas, you hit something like, oops, C5, I don't know, Lanuza. And then you hit something like C5 Taguig area. And then if you have to go through Makati, you have to hit BGC here. No? Okay. And then let's have this other route down here as EDSA. So taking Katip, how do you get to EDSA? How would one get to EDSA from Katipunan? I think, I don't know. What's that place? Katip Extension, and then Boni Serrano. So we have Boni Serrano here. And then once we pass that, we hit something like, I don't know. Correct me if I'm wrong, or just chime in. I'm not really good with EDSA. I don't really pass EDSA a lot. Let's call this the Pioneer area. Or what comes before Pioneer, and then let's call this EDSA show. Okay. And then once you're past show, something like, I don't know, EDSA Guadalupe. Once you're past that, you're something like near EDSA Yala. Okay, let's fix this. Makati CBD. Yeah, once you get there, you can get through some CBD now. Okay, these other routes. So this might be the in-between of C5 and EDSA. No? So this is going to be the Ortigas CBD. And there's that bridge no, between Ortigas and BGC now, the Pasig BGC bridge. Let's call this other one here from Pioneer to Ortigas CBD. Something like maybe Mandaluyong central area. Okay, so regardless, and I hope my graph is right. This is the path that one would use. This is a set of all possible paths, no, that one would take if you wanted to go to Makati Central Business District from Katipunan, from that's the Ateneo. And how heuristic search works is you traverse the graph based on the distances and time and estimates that you have as you near your objective. No? So let's say we have a constraint. Let's work with, let's say, what is this? 3 p.m. You have an internship in Makati, you're coming from Ateneo, there's no pandemic, you have to go there, you leave at 3 p.m. What time do you get to Makati? No? So at 3 p.m., if we're based on Katipunan, we know that from Katip to C5 Eastwood. Wait, sorry, this is a bad. Let's remove this. This maybe has a path. Okay. So, ayun, at 3 p.m., that's uwian, all the school buses are out. Taking Boni Serrano or taking Eastwood would likely, I don't know, cost you 30 minutes, 20 minutes. Let's put it at a cap of 20 minutes now. So let's put this cost to 20 here. Okay. C5 Eastwood to C5 Ortigas. At that time, you're against the flow of traffic. So let's say that does you 15 minutes. Maybe 10. Shouldn't be so bad. Okay. C5 Ortigas to C5 Lanuza. That's where it kind of piles up na, no? So let's say you get 15 minutes there. C5 Lanuza to C5 Taguig. That's a choke point. So let's say you do something like another 15 minutes there. C5 Taguig to BGC at around 3 p.m. No? By our first estimates, this is something like, I don't know, 5 minutes. From BGC to Makati, it would take you something like 10 minutes to cut through all the stoplights, no? These numbers in gray are all of our estimates, at least for the C5 route as of 3 p.m. Okay, let's continue with the 3 p.m. estimates. Okay, so Boni Serrano to EDSA Pioneer, that would what? Take you, I don't know, 10 minutes. Pioneer to Shaw, it's probably what, 3 minutes long. Shaw to Guadalupe, probably 3 minutes as well. EDSA Guadalupe to EDSA Ayala, that's probably gonna do you 5 minutes. Ayala to Makati CBD, that's what, 2 minutes lang. Okay, now let's fill in the other edges. EDSA Pioneer to Mandaluyong, that's practically, I don't know, the same place. So let's do 2 minutes. So, sorry, we're driving. So let's say it's 3 minutes. Mandaluyong to Shaw, another maybe 3 minutes. Mandaluyong to Ortigas, maybe 5 minutes, 10 minutes because all the stoplights. And now Ortigas to BGC. I've never really tried that route, but I'm assuming it would do like 15 minutes because of all the stoplights in Pasig. Vicos auto stoplights take forever. BGC to EDSA Ayala, probably 10 minutes, no, through BGC stoplights. So these are all our estimates at 3 p.m. So what looks like the best path, let's have another something here, 10 minutes. Eastwood to Mandaluyong, 15 minutes. Okay, so what looks like our best path here, we can't really tell yet, no? So at time 3 p.m., our starting from Katipunan, our best option would be likely to take either Boni Serrano here or Katipunan here. And it looks like EDSA has the shortest amount of cost, the shortest amount of time, no, at 3 p.m. So while both C5 Eastwood and Boni Serrano have the same cost, we know at 3 p.m. that, okay, this is 20 plus 10, 30, 33, 36, 41, 43 minutes from Katipunan to Makati CBD at 3 p.m. At that moment, no? If there were no travel time involved, but that's not how things work. And this is how heuristic search happens. As you progress from, let's say, one node to another, from, let's say, sorry, let's get something yellowish. From taking our position now, no, from Katipunan to Boni Serrano, it's now 3:20. So all of our estimates here have now changed, no. We know that upon 3:20, 3:30 even, traffic exponentially grows and all of our estimates will change. So let's see how that works. So let's have a new set of estimates here. Let's have it in blue. So, sorry, let's fix this. Let's put this to gray so that it's all clear. In blue, let's do it 3:20. Okay, so at 3:20 in blue, all of these things change, no? This will likely be 15 now. This will likely be 6 now. Let's say it all doubles, no? This will likely be 6, 6, 20, 6. Hindi naman siguro 13 minutes to. Natin 20 minutes. 10, 5, 15, 15. Ayan. Okay. So what I'm doing here is as I move closer to my goal, my estimates become more realistic because I essentially travel and time elapses. Our estimates will change and they will become more realistic as we go along. So, okay, given that we're here in Boni Serrano, there's no other edge to traverse. No? There's no other path to take. So the only option we have is to take EDSA Pioneer and we're now here. Now, sabihin natin, time hasn't really, so it's 3:20, we have a plus 15-minute penalty. So let's have it in red. 3 plus 15, 35. Oops. Okay. So now we have a plus 15-minute penalty. So our estimates will change. This is now probably going to be 10 minutes. This is now going to be 10 minutes, 10 minutes, probably 25. This is probably going to be something like 10 minutes, 25, 15, 20, 20. Let's say this is 10. And so given this new knowledge that we have now, we're now at EDSA Pioneer, and it looks like we have potentially new ways to get to Makati CBD. Do we cut through Mandaluyong Ortigas to get to Makati, or do we take EDSA? So let's sort of compute the cost now. Taking this route will cost us 10, 10, 15. So that's 35 plus 10, 40 minutes. An additional 40 minutes using this path here. If we take an alternative path, so this is it. So let's say this is 10, 25, 35 plus 25. So 60 minutes kagad to. Cutting through Ortigas is the bad option. So we ignore this route here. So these are all ignored routes now. We ignore this route given that if we take EDSA Shaw rather than Mandaluyong, our options look better than they generally do if we take the options that are accessible from Mandaluyong. So let's proceed. Okay. Yeah. Now we're here at EDSA Shaw plus 10 minutes. So let's have another. I'm running out of space here. Estimate here. So let's do, what was that? Plus 10 minutes. So 3:40 na tayo. So now that we're here at EDSA Shaw, let's say that, traffic hasn't really changed. It's at its somewhat first peak because there are multiple peaks to traffic now. So we have here EDSA Shaw. This is going to be 10 minutes. This is going to be, we didn't put an edge here. Let's say from EDSA Shaw to Ortigas, this is going to be 15 minutes. Ortigas CBD to BGC, probably 25 pa rin yan. Wouldn't change so much. 15 minutes here on EDSA because of the volume. Let's put it to 20. Put this to 20. Put this to 15 minutes. Okay. So given that we're now at EDSA Shaw, we have this option here, or this option, or this option, or this option. So we have a series of multiple paths that we can take. So we can take EDSA, Ortigas CBD, through BGC to Makati. That's one way we can take. We have EDSA, Shaw to Guadalupe, to BGC, to Makati CBD. We have EDSA Guadalupe, to EDSA Ayala, to Makati CBD. That's another path. So let's find the most optimal one that we have. So given everything that we know, so this is 15 plus 25, that's 40 plus 20 minutes, 40 for, sorry, what? 15 plus 25, 40 plus 20 minutes, 60. So we have here, this looks like a horrible one to take, because if we traverse the nodes available from Ortigas, it will take us an hour. And let's take this one here, from EDSA Shaw to EDSA Guadalupe, considering it's probably going to be a lot less than an hour. No? So plus 10 minutes, it's now 350. I'm running out of space. 350. Okay. So at 350, our estimates change again. Traffic, halos uwian na yan. Let's say this expands itself into something like, I don't know, 25 pa rin. 20, 20. Okay, so nothing really changed. So from EDSA Guadalupe, we have these paths available. EDSA Guadalupe, BGC, EDSA Ayala to Makati, long path. Pwedeng EDSA Guadalupe to BGC to CBD. Pwedeng EDSA Guadalupe, EDSA Ayala to Makati CBD. Let's compute for the most optimal one. Okay, so 350, looking at the green nodes. So this is 15 minutes, 15 minutes, 30. Okay, this is 25 plus 10, 35 minutes. 25 plus 20, we didn't tag this. Let's say this is 5, 10 minutes. Yeah, this is 25 plus 10, 35 plus 15. That's going to be 50 minutes. So, okay, we know that this is not going to be a good choice. The best choice will likely be this one here. No? So that's plus 15. And then given that we have no other node available from EDSA Ayala, we just might as well continue. Oops. We just might as well continue on to here. Okay. So TLDR, that's generally how heuristic search works. What a heuristic is, guys, is it's an estimate. It's a criteria that we use to essentially solve decisions, to process decisions. No. So in this case, my heuristic, as I expanded each node, was to look for the shortest path in terms of time, given the remaining nodes available. No. What does that mean? So I could have just taken C5 based on these paths. It looks good, no? But knowing that the total cost of taking C5, at least at 3 p.m., was a lot more expensive than the total cost of taking EDSA, we take the shortest one given the information that we know, no? And here's the catch. Not all heuristic search algorithms provide the best and optimal solution. No. At 3 p.m., we took EDSA because we knew that it was the fastest at 3 p.m. But what if it was 3:35 na and we were somewhere here? What if C5, the C5 route did not change in terms of cost? Given C5, after 3 p.m., maluwag na yan dahil wala ng mga truck yan. No? So traffic should be decreasing, no? As we progressed maybe through time here. So baka naging 10 na lang to, 5, naging 10 to, tapos naging 5 lang to. And then maybe on pagdating na 3:40, halos wala ng tao dyan. 3 minutes na lang to, 5 minutes na lang yan, 5. So you get what I'm trying to bring forth here, no? That um, given the information you're provided, you try to make the best option, the best decisions that you can. It might not be globally the best solution, ano, but given where you are, given what you have available, given the heuristic that you're working with, this is how search works. This is how agent-based systems work. This is how graph traversal will work. No, normally I would take C5 because I know that after 3 p.m. trucks are gone. Traffic will likely decrease before it spikes at something like 5 p.m. No, but that's not the heuristic I was working with. The heuristic I was working with here was at 3 p.m., which was the fastest route. And this is the problem with using Waze um, and the time estimates that they give. No, Waze, I love Waze, but there are times when it just the estimates are way off once you start driving because the estimates that they give you are the estimates at the actual time that you look at it. It's not the estimate as you go along. No, it doesn't really forecast load. It doesn't forecast traffic as you go along. And this is the problem that I illustrated here. If you took EDSA, sabihin natin, okay, Katip at 3 p.m., Katip through C5 to Makati would take you 40 minutes. If you take EDSA, it's 30 minutes. But that's assuming that you don't encounter any increases in traffic. You essentially just teleport. You don't go through various obstacles. There's no change in traffic now, but that's not how the world, excuse me, works. That's not how reality works now. And there are various nuances in how we increase our information, our understanding of our environment gets better as we traverse the graph. No, so this is something that you guys will learn later on as Doc Dre discusses problem-solving agents, agent-based systems. But as you traverse the world, your objective is to still get to your goal. But as you traverse, you get more information, and this information helps you make the best decisions that you can. So what I just illustrated to you guys is a very greedy algorithm that doesn't optimize for a global solution. It optimizes for what's immediate, what's at hand, no? Sabihin natin, tumingin lang siya ng Waze nung simula. It saw, okay, EDSA is faster than C5. And then he did not use Waze any further, no? What he just does is check the estimated travel times per checkpoint, but doesn't do any rerouting, doesn't look at other routes. And this is maybe, realistically, not the best way to navigate traffic. But this is how a lot of AI systems work. They have limited information. They have a goal, an algorithm that they have to process and abide by. And this is how that sort of algorithm um, leads them to tackle their environment and world. No, so I hope this illustration, this lesson was somewhat interesting to you guys. Illustrating heuristic based search is challenging, and this is something that you guys will be very, how do I say this, you guys will get a lot used to this once you start working on um, AI systems, agent-based systems, agents, and their problem-solving properties. So be fairly used to and be fairly comfortable with graphs, BFS and DFS, how they can be represented as queues or stacks, kung last in, first out siya or first in, first out. Let me know if you have questions. Now, graph theory is one of my favorite topics, so I'll be more than happy to answer any questions or clarification you guys have with graphs and networks. I hope you guys learned something from this short session. There's a question. Ayan. Is time always involved in heuristic search? And to clarify, does heuristic search only consider the present time? This is the interesting problem, no? For the travel problem that I presented, time was the heuristic I used, but it doesn't have to be. If we go back to the RPG skill tree demo or example that I had, the heuristic I would use is which skills would lead me to get to the build that I want. No, not the heuristic is something arbitrary. It's a criteria that you program into your agent. It's a criteria that can be totally anything that you want. So if I want to travel from Katipunan to EDSA, I can have my heuristic to be road quality. No, if I wanted road quality to be my heuristic in this case, I'd probably just take the Ortigas route because roads there are nice. C5 roads suck. EDSA, meh. So you get what I'm saying. Yung heuristic is any criteria that will make you decide which node to select, which next node to select. If I start at Katipunan and I have road quality as my heuristic, no? Sige, sure, I'd go with C5 Eastwood first. And then once I'm at Eastwood, I see the really horrible truck lane on C5. And I decide to go to Mandaluyong because the roads there are nicer. Thank you, Pasig. Thank you, Mandaluyong. And then, okay, I wouldn't go to EDSA because I know that EDSA roads are horrible. So I just continue along Mandaluyong, knowing that the roads that I will take as I expand, as I traverse the graph, have higher quality roads. That's one heuristic that I can use. Another heuristic that you can use for this travel use case is cost, no? How much fuel do you consume? Depends. It might be correlated with time, but for the most part, it doesn't, no? So, pwede dito heuristic mo travel time, road quality, number of accidents, likelihood of accidents. It could be if you're some hyper paranoid guy, and you want to avoid traffic accidents, no, you will select routes that have the lowest likelihood of accidents happening. That's a heuristic that you can take. For a Roomba, for a vacuum cleaner, that's a robot. The heuristic it will take, no, is have I cleaned this area or not? Have I been here before? The heuristic that I will take if I work through a skill tree of my RPG character from playing Skyrim is which skills will lead me to be the most lethal in whatever character build I want to do. So if it's the magic school, if it's the assassin school or the archery school or the swordsman builds, syempre, I will prioritize those skills, those nodes that will eventually lead me to my end goal. So this is what a heuristic is, no? It's not necessarily time or travel time or something like that. It can be any criteria that you want. I just use time here on this plot, no, kasi it's a very real world scenario. But given any tree, given any graph, given any problem that you can represent as a graph, whatever heuristic you can figure out for that could be anything. Yeah, so I hope I answered your question. I might have gone on a bit of a digression there. So any other questions? Yeah, just to reiterate, no, heuristics can be anything. What matters is how your heuristic relates to the environment or the world that you're working in. Ano? So the one I use, time, is a very greedy heuristic. It did not give me the most optimal solution. It gave me an okay solution. It's not the best one, ano? Kasi if I took Eastwood, C5 Ortigas, baka mas mabilis pa ako nakatawid. But given the heuristic I was looking at, um, which one is the shortest path in terms of time immediately, that's the heuristic that I used, and this is what I ended up with. No, so that these are some of the challenges that AI systems, agent-based systems will encounter. So I'll stop the share here. Let's do that. Ayan. So any questions, guys? Yeah, if not, I think we can end here. I hope you guys found this lesson useful. We'll follow up with some assessment on Friday that will involve everything that we've discussed previously, intro to AI, history of AI, and graphs. Stand by for a lesson on Thursday with problem solving agents with Doc Drano. I think he'll be uploading an async lesson on that. So yeah, if there are no more questions, thanks guys.
Yes, sir. Thank you.
Hope you guys enjoyed the lesson. Stay safe and have a great day.
Bye, sir.
Bye,
Bye.
sir.